All right, here we are in the very last video of the year, which feels wild, but this is it. So we're just doing the last properties of exponents. These are pertaining to division. So whenever you see a fraction, you're going to use these properties. So the first one, you have 2 to the 7th over 2 to the 3rd. So thinking about what that means, 2 to the 7th is 2 multiplied by itself 7 times. So in my numerator, I'm going to write 2 times 2 times 2 times 2 times 2 times 2 times 2, 7 times. And in my denominator, 3 times. Whenever you have 2 over 2, it just cancels out. So I'm going to cancel this one out, and this one out. So I'm left with 2 times 2 times 2 times 2, which is 16. And that's the same thing as 2 to the 4th. So how did I get from 2 to the 7th over 2 to the 3rd to 2 to the 4th? Well, I subtracted the exponents. So your shortcut here is subtract your exponents. So if I have, for example, x to the 7th over x to the 3rd, I can simplify that by doing x to the 7 minus 3, which is x to the 4th. All right, let's do some examples. So example 1, you have x to the 3rd, y to the 4th, over x squared y. And you only do these properties with the like terms, just like we did with the multiplication ones, okay? So x to the 3rd over x squared, I'm going to subtract those two exponents. 3 minus 2 is 1. So I have x to the 1st. Y to the 4th over y, it might help you to write that little 1 in there. Y to the 4th over y to the 1st, 4 minus 1 is 3, so I have y to the 3rd. And you can just write that as x y to the 3rd as shorthand if you'd like, and that's your answer. Then I have, on letter B, I'm going to do the m's first. M to the 7th over m to the 5th, subtract 7 minus 5, which gives me m squared. N to the 10th over n to the 3rd, which gives me n to the 7th. And then my p's actually just cancel out. So there's my answer. All right, power of a quotient. Now you have 1/2 to the 4th power. I know it's written kind of weird, but maybe it helps you to view it like that. You have a numerator and denominator raised to the 4th power. And what you're going to do on this is distribute to both the numerator and the denominator. So now I have 1 to the 4th over 2 to the 4th. Okay, 1 to the 4th is just 1, okay, because 1 to anything is just 1. 1 times 1 times 1 times 1 times 1 times 1 would still be 1. 2 to the 4th, that gives you 16. Okay, again, it's not 8, that's not 2 times 4, it's 2 times 2 times 2 times 2, which is 16. And that's that. So, using symbols, what this means is, for example, if you had x over y to the 4th power, that would be the same thing as x to the 4th over y to the 4th. All right, couple examples. So you have 3x to the 4th over 4 to the 3rd power. You're going to distribute that 3 to every single piece of what's inside your parentheses. So first of all, you have 3 to the 3rd. X to the 4th to the 3rd power. This goes back to your power of a power property from the multiplication properties, and you're going to multiply those together. So 4 times 3 gives you 12 over 4 to the 3rd. Then to simplify that, I need to simplify down my actual numbers. So 3 to the 3rd, if you plug that in your calculator, I didn't say this on the previous video, but you can also plug it in Google if you want to. If you type in 3 caret, which is shift 6 to the 3rd, that will give you your answer on Google. So 3 to the 3rd gives you 27, x to the 12th over 4 to the 3rd gives you 64. And there is your answer. Same thing on letter B. I'm going to distribute that 3 exponent through to every single piece of what's inside my parentheses. So I have 4 to the 3rd, x to the 3 times 3, which is 9, over 5 to the 3rd, y to the 4 times 3, which is 12. Then I simplify my actual numbers. So 4 to the 3rd gives me 64. I have x to the 9th. Over 5 to the 3rd gives me 125. Y to the 12th. And there's my answer. All right, the last couple properties here. 0 exponent property. This one's super straightforward and super fun. Okay, so 0 property, what this says. If you raise anything to the 0 power, it's 1. I don't really need to get into the math behind it because I think it might just confuse you. It's just kind of one of those things where just accept it, all right? It's a weird rule of life, but just accept it. So if I have x to the 0 power, that's 1. If I have 7 to the 0 power, that's 1. If I have a, b, c to the 0 power, that's 1. Anything to the 0 power is 1. So on letter A, you have b to the 4th, c squared d to the 0 over b squared c. I'm going to simplify the b's and the c's first of all. So b to the 4th over b squared. Again, I'm going to subtract my exponents. So 4 minus 2 gives you b squared. C squared over c to the first, I'm going to subtract 2 minus 1, which gives me just 1. So that's just c. And then d to the 0, that is 1, which means it just cancels out here. Because if I multiply that times 1, it doesn't change the value. So this is actually just my answer. And then on letter B, you have all this confusing garbage inside your parentheses, and it doesn't even matter because all of it is raised to the 0 power. If all of it's raised to the 0 power, it's 1. Yes, true story. You don't even have to look out in the parentheses. If a set of parentheses is raised to the 0 power, it is equivalent to 1. True story. All right. Now, lastly, you have negative exponent property. Okay, there are such things as negative exponents, but we kind of use this little trick to take care of that. So if you get x to the negative 2, for example, that's the same thing as 1 over x squared. So I basically flip the exponent, the base and the exponent together into the denominator, and I get rid of the negative that way. Works vice versa as well. If you had 1 over x to the negative 2 and you flip it back over, you get x squared. So on example 4 there, on that first one, I have v to the negative 3. That's my first negative one. Negative exponent, and then y to the negative 6th. So I'm going to move y to the negative 6th up to the numerator. I'm going to move v to the negative 3 to the denominator. So in my numerator now, I have wx squared y to the 6th. Okay, so I just completely get rid of that negative sign. Now it's positive. V to the negative 3 becomes v to the positive 3, and then I have that w from the bottom. To simplify this, w over w, that cancels, okay? Nothing else simplifies because you just have an x, a y, and a v. You can't do anything there. So my answer on that one is x squared y to the 6th over v to the 3rd. All right, then on letter B, I'm going to start by moving around some stuff. So a to the negative 8, c to the negative 4th, and c to the negative 2 are my negative exponents. So I'm going to start by shifting the a down to the numerator, the denominator, excuse me. I'm going to switch around the c's. I'm going to c to the negative 4 to the bottom and c to the negative 2 to the top. Get rid of those negatives. So I have, first of all, 32 b to the 3rd, c squared, because I moved the denominator part up to the top. Then I have 8, a to the 8th, a to the 3rd, b to the 5th, and then my c that I've now moved to the bottom is c to the 4th. Right now, I just got to simplify. So first of all, 32 over 8, when you look at your whole numbers, just think of it like a fraction or a division problem. So 32 divided by 8 is actually just 4. Okay, so that's my simplified version of 32 over 8. So I'm done with that. Then, let's see here. In my denominator, I have a to the 8th times a to the 3rd. I can combine those, okay? That's that multiplication property. I'm going to add together my exponents. 8 plus 3 gives me 11, so that's a to the 11th. So I've taken care of that. Then I have b to the 3rd over b to the 5th. If you do b to the 3 minus 5, you end up with b to the negative 2, and you are back to square 1. You end up with a negative exponent. So a little trick, if the number in the bottom, if the exponent in the bottom is bigger, just subtract the bottom minus the top, and then your answer ends up in the bottom. So b to the 5th, I'm going to subtract 5 minus 3, okay, which gives me b squared. Since b to the 5th is in the denominator, that's the bigger number, I'm going to put b squared in the denominator, okay? You can also think of it like this, b times b times b, that's b to the 3rd, or b times b times b times b times b. 3 of those cancel out, and I'm left with 2 b's in the bottom, which is the same thing as b squared. Okay, that's just a way to think about it. Same thing with the c's. 4 is bigger, so my c is going to end up in the bottom. 4 minus 2 is 2, so I get c squared in the bottom. Or again, you can think of it as c times c over c times c times c times c. 2 of the c's cancel, you're left with 2 c's in the bottom. And there's your final answer. And that is it. That's it for Math 1. That's all you got to learn in Math 1. Now, the only thing that stands between you